Random access memory is a type of computer memory that provides temporary storage for data that the CPU is currently working on. RAM is an essential component in any computer, as it allows the CPU to access data which can significantly improve overall system performance. There are several different types of RAM, including DDR4, DDR3, and DDR2, each with different speeds, power requirements, and compatibility with different systems. The amount of RAM in a system can also vary, with many systems offering anywhere from 4 GB to 64 GB or more. DDR2, DDR3, and DDR4 are different generations of RAM, random access memory, modules used in computers, with each subsequent generation offering faster data transfer speeds and lower power consumption. DDR stands for double data rate. Corsair Vengeance LPX DDR4 is a high-performance RAM is designed for use in gaming systems and workstations, and it offers speeds of up to 4000 mHz and capacities of up to 128 GB. Kingston HyperX Fury DDR4 is affordable, high-performance RAM designed for use in a wide range of systems, and it offers speeds of up to 3733 MHz and capacities of up to 64 GB. Skill Ripjaws VDDR4 is a high-performance RAM designed for use in gaming systems and workstations, and it offers speeds of up to 4600 MHz and capacities of up to 128 GB. Samsung DDR4 SODIMM is a low-power RAM is designed for use in mobile devices and other low-power systems, and it offers speeds of up to 3200 mHz and capacities of up to 32 GB. A hard disk drive, HDD, is a type of computer storage device that uses magnetic storage to store and retrieve digital information. HDDs are one of the oldest and most common types of storage devices, and they are still widely used today. A hard disk drive, HDD, is typically connected to the motherboard of a computer via a SATA, Serial Advanced Technology Attachment, or an IDE, Integrated Drive Electronics, interface. The SATA interface is the more modern of the two and provides faster data transfer rates, while the IDE interface is an older standard that is less commonly used today. In either case, the HDD will be connected to a specific port on the motherboard and will require power from the computer's power supply unit, PSU, in order to operate. Magnetic storage disks, such as hard disk drives, work by using a magnetic head to write and read data on a rotating disk coated with a magnetic material. The magnetic material is divided into small areas called magnetic domains, which can be magnetized in one direction or the other to represent the binary digits. To write data to the disk, the magnetic head generates a magnetic field that aligns the magnetic domains in the direction corresponding to the desired bit value. The disk rotates under the head, allowing the magnetic field to magnetize the appropriate domains in sequence to create the entire data pattern. To read data from the disk, the magnetic head detects the changes in magnetic polarity of the magnetic domains as they pass under the head while the disk is rotating. The head then converts these magnetic changes into electrical signals, which are interpreted by the computer's hardware and software to recover the original digital data. The data on a magnetic storage disk can be rewritten many times, making it a flexible and versatile storage medium. However, magnetic storage disks are subject to physical wear and tear, which can cause data loss or corruption over time. Some of the major manufacturers of hard disk drives include Western Digital WD Blue. The WD Blue is a popular consumer-grade hard drive that offers a balance of performance, capacity, and price. Seagate Barracuda. The Seagate Barracuda is another popular consumer-grade hard drive that offers good performance and reliability. Toshiba X300. The Toshiba X300 is a high-performance hard drive designed for demanding applications such as gaming and video editing. Samsung 970 EVO. The Samsung 970 EVO is a popular solid-state drive, SSD, that offers high-speed performance and reliability, making it a popular choice for gamers and professionals who need fast storage for their work. A graphics card, also known as a video card, GPU, or graphics processing unit, is a hardware component that is responsible for rendering images and videos on a computer. Rendering is the process of generating an image or video from a 3D model or scene. In computer graphics, a 3D model is made up of a collection of objects, each with its own appearance, texture, and lighting. Rendering takes this 3D data and converts it into a 2D image or series of images that can be displayed on a screen or saved as a file. The rendering process involves several steps, including calculating the position and color of objects in the scene, determining the lighting and shadows, and applying any post-processing effects such as blurring or color correction. The complexity and time required for rendering can vary depending on the level of detail in the 3D model, the number of objects in the scene, and the quality of the final output. NVIDIA is one of the leading manufacturers of graphics cards, and their products are popular among gamers and professionals alike. Some popular NVIDIA graphics card models include the GeForce RTX 3080, GeForce RTX 3070, and the GeForce GTX 1660. AMD is another major player in the graphics card market, and their products are known for their affordability and high performance. Some popular AMD graphics card models include the Radeon RX 6800 XT, Radeon RX 6700 XT, and the Radeon RX 5700 XT. MSI is a well-known manufacturer of graphics cards, motherboards, and other computer components. Some popular MSI graphics card models include the MSI GeForce RTX 3090 Gaming X Trio, MSI Radeon RX 6700 XT Mech 2X, and the MSI GeForce GTX 1660 Super Gaming X. Asus is another popular manufacturer of graphics cards, and their products are known for their quality and performance. Some popular Asus graphics card models include the Asus ROG Strux GeForce RTX 3070, Asus TUF Gaming Radeon RX 6800 XT, and the Asus Dual GeForce GTX 1660 Super Evo. A computer power supply unit, PSU, is a hardware component that converts AC power from an electrical outlet into DC power that can be used by the various components of a computer. The power supply connects to the motherboard usually in two places: ATX 24-pin power connector. This is a large, rectangular-shaped connector that provides power to the motherboard. It is usually located near the right edge of the motherboard. CPU power connector. This is a smaller, square-shaped connector that provides power to the CPU. It is usually located near the CPU socket, which is usually in the upper left corner of the motherboard. The power consumption of a computer system depends on the components installed and the workload being performed. Here are some typical power consumption values for each unit in a computer. CPU. A typical desktop CPU can consume anywhere from 20 W to 150 W depending on the model and workload. High-performance CPUs for gaming or workstation use can consume even more power. GPU. A typical desktop graphics card can consume anywhere from 75 W to 300 W depending on the model and workload. High-end gaming or workstation graphics cards can consume even more power. RAM. RAM modules typically consume very little power, with most modules consuming less than 5 W. Hard drive, SSD. The power consumption of hard drives and SSDs varies depending on the model and workload, but generally ranges from 2 W to 8 W. Motherboard. The power consumption of a motherboard depends on the components installed and the workload being performed, but generally ranges from 20 W to 50 W. The overall power requirements of a computer system depend on the total power consumption of all the components installed. A typical desktop computer with a mid-range CPU and graphics card, 8 GB of RAM, and a single hard drive or SSD might consume anywhere from 200 W to 400 W under typical workloads. A high-end gaming or workstation computer with a high-performance CPU and graphics card, multiple hard drives or SSDs, and a lot of RAM might consume anywhere from 500 W to 1000 W or more. It's important to choose a power supply that can provide enough power for your system without being underutilized or overloaded. A power supply that is underpowered can cause instability and crashes, while a power supply that is overpowered can be inefficient and waste electricity. When choosing a power supply, it's recommended to choose one that can provide at least 20% more power than what your system requires to ensure stable and reliable performance. Some popular power supply brands include Corsair, EVGA, Seasonic and Silverstone. The BIOS, Basic Input-Output System, is firmware program that is stored on a computer's motherboard, and it is responsible for controlling the initial startup process of the computer. The BIOS provides a low-level interface between the hardware components of the computer and the operating system, and it contains settings and configuration information that control how the computer operates. The BIOS is typically accessed by pressing a key, such as F2 or delete, during the boot process. This brings up the BIOS user interface on the computer screen, which allows the user to view and modify various system settings and configuration options. The BIOS user interface is typically a simple text-based interface, with menus and options that can be navigated using the keyboard. BIOS user interface, also known as BIOS setup utility. The user interface for BIOS is typically stored in the BIOS firmware, which is stored on the BIOS chip on the motherboard. The CMOS memory is implemented using a small amount of low-power static RAM, SRAM, and a battery backup circuit. When the computer is powered off, the battery backup circuit provides a small amount of power to the CMOS memory to keep its data intact. The CMOS memory also has a special section called the real-time clock, RTC, that keeps track of the current date and time even when the computer is powered off. The RTC is powered by a separate battery that is designed to last for several years. Overall, the combination of SRAM and battery backup circuitry allows the CMOS memory to retain its data for long periods of time, even when the computer is turned off. Dynamic RAM, DRAM, uses a capacitor to store each bit of data, which must be periodically refreshed to avoid losing the data. Static RAM, SRAM, uses a flip-flop circuit to store each bit of data, which does not require refreshing but is more expensive and consumes more power than DRAM. Leading manufacturers of CMOS include American Megatrends Inc., Phoenix BIOS, Avod BIOS, Dell, HP, Lenovo, Asus and MSI. Before installing a BIOS, we must check compatibility with other components.